All right, here's part two of the review. I'm going to try to do this a little bit faster. I've got all these exponent problems here. I'm going to try to get through these as quickly as I can. Just to kind of explain, so here I'm asking you to use the exponent of 2, and I'm asking you to square what's here inside the parentheses. So the basic idea is this. If you're squaring a number like 2, then all that means is you're writing it out twice and multiplying it together. That's how you do that calculation. So the same thing applies here. You can just write this out twice and then apply that calculation. W third, 10, W to the third. Now, multiplying those two things together, 10 times 10 is going to be 100. And what's happening here is we have 3 W's times 3 more W's. So that means that there's a total of 6 W's being multiplied together. Taking that, now we have our fraction here. Now at this point, it's going to be division. So 10 divided by 5 is 20. There are 6 W's in the top part of the fraction, and I'm dividing by a single W. So dividing, I can eliminate 1, and what's left over are 5 of them. Okay, so for number 6, that would be your final answer. Moving on to 7. I'm going to rewrite the problem real quick. Alright, so I've written out each of the parts. Now I've written it out this way so that you have each thing separate. So you have the numbers, the x's, the y's, the z's. Now just putting negative 15 over negative 45 in your calculator, you're going to get a third. Approaching these others, all that we're doing here is subtraction. The same way we had w to the sixth, I divided by a single w, it eliminated down to 5. So 7 x's divided by 3 x's is going to be, eliminate that down to 4. Now I'm going to have x to the fourth. Same thing here. 5, take 8, eliminate 5 of them. That's going to be y to the third. Take 4 z's, eliminate 3 of them. It's going to be z to the first. Now the thing I want to clarify here is these are all still fractions. So your final answer is going to have a fraction because there is a 1/3 still. So your final answer would look probably like that. Alright, let me set these other two up. Alright, number 8. This is just put it in the calculator. So what I've got here and the way that I've written it out is I have the inner part, that's this, and then I have the outer part, that's that. I've done all the parentheses the same. The thing that's important here is that you include parentheses here on this exponent with the 1/2. And you're just putting that in your calculator, pressing enter, and getting an answer of 64. That's all that entails. And I'll pull up the calculator and show you real quick. Alright, so you can see here that I have everything put in the same way that I have it written down. Enter, answer 64. I'm pretty much going to do the same thing with number 9, and so I'll show you real quick how that gets put in the calculator. So here I have 4 over 9, 4 over 49, the parentheses, same exact way as in the problem. 3 over 2, 3 over 2, same exact way as it is on the paper. Now that's a weird decimal. See if you can change that over to a fraction. And so the way I did that, I pressed math, enter twice, and it comes up with the fraction 8 over 343. So that would be your final answer. There we go. Alright, moving on to number 10. Alright, here I have the function entered in for number 10. It doesn't matter if you have the x on the inside or the outside. Whoops, forgot a negative here. Let me go back and fix that. And then I'll pull up the table. Okay, so what we're dealing with here is I've an exponential function. I've already entered it into the calculator. I'm looking at the table now. I'm just going to take some of these points. Doesn't matter if it's 100% accurate or not. I'm going to plot them over to here. And then I'll write down which points I'm plotting so you can see after I've done it. Alright, so there are the 4 of the points plotted, the ones that I felt I could plot the best. This barely fit on here with that -6, but you can see here, starting with -2, I was able to plot those 4 points there. Now I'm going to go ahead and start it on the y-intercept and all that information over there to the side. So the y-intercept is pretty obvious. That one's going to be 0, -3, because, well, there's the y-intercept. So I don't have to worry about that too much. The second thing that's pretty easy is domain. That's going to be all real numbers. And that's because this graph is going to continue over to the right and over to the left, which means that all x values are covered there. And now range is a little different. Range going from bottom to top is going to be from, well, infinity, because there's an arrow here, up to the top, which is 0. So that means that from left to right, or from bottom to top, I'm going to have 0 on top, and there is no number on the bottom of the graph here. So actually my range is going to be y is less than 0, which makes sense because the whole graph is here below 0. So the asymptote is going to be the line that this graph cannot cross, and that line is actually the x-axis. And the equation, the asymptote is an equation. The equation for that is y equals 0. So that line, y equals 0, is the line that the graph cannot cross. Quadrants, I'm going to label the quadrants real quick. Okay, so I've got the quadrants labeled. Now what I'm going to do is, well, just to kind of explain it a little bit, quadrants start with quadrant 1 in the double positive area. 1, 2, 3, 4 goes counterclockwise. The graph is in this bottom half. That would be quadrant 3 and 4. It's kind of silly, and I know that you've learned quadrants before, but we know it's going to be on the test. So there you go. Moving on to the back, or actually the last one here at the bottom of this page. So 11, there were originally this many spores in a petri dish. There were 10% fewer spores after each inspection. So because that is fewer, that's going to be decay. So what we're doing is we're taking the 460, that's the 100%, and we're subtracting 10% of that. So what we'll end up with is really 90%. So that's what we're looking for. There's our answer. Starting with 460, calculated the percent, the factor. There we go, done. Moving on to the next page, number 12. All right, number 12, you can read through that yourself. Here's the question: which of the following best describes the meaning of the value 1.25? This has to deal with our percent. Now, it does not directly go to the percent, but it's what you have after you add your percent on. Because this percent is over 100%, I know that it's addition, I know that it's growth. Now what that percent has to be, and if you want a way to calculate it, just take the 125, subtract 100 from that, and that'll tell you that 25% is really what your rate is. Now because it's greater than 100, I know it's increasing, not decreasing. Because it's plus 25, it's now 25% a year. Answer is going to be C here. Okay, moving on to number 3. All right, number 13, write an exponential equation so you know that you're going to be doing an exponential regression. That's going to be using your calculator. So I'm going to get this table of values, enter it into the calculator real quick, and we'll pick up there. All right, as you can see, the same numbers that are here for the table are in the calculator now. After I've entered that information in, I'm going to be going back into stat. Now how I got here, stat, edit, press enter, that pulls up my table, I entered the values, stat, over to calculate, and I'm going to be doing a exponential regression, so I'm just going to go down until I get to exponential regression. That's what I want to do, enter to start it. There are my numbers. I have the diagnostics turned on. This tells me this is a 100% match. So there's my equation, those are my numbers I'm going to use. I'm going to get it written down now. Alright, number 14, simplify the expression. You have a negative sign there with parentheses. It's basically distribution, so it's like distributing a -1. I'm going to go ahead and do that real quick just so you can see. So there are all the arrows for the distribution. Once you distribute, you'll have this. Now it's just combining like terms, so I'll do that real quick. So I got everything underlined. Now I'm just going to go ahead and combine each of the ones that I've matched here. And there you go. That's the last question. Good luck, guys.